morning, grade 11s, and welcome for joining me this morning on the mathematics webinar. As you all know, I always allow for a minute or two just for other attendees to sign in and join us this morning so that they don't miss out on something. So I will see you in 2 minutes. So good morning, grade 11s. If I did not greet you this morning already, welcome to this morning's webinar. Before we start, I would like to go through some basics so that all of you know what is expected of you and how this session will work. If you don't know me by now, I am Linky Young and I am the Chief Education Specialist at Impact for Mathematics and Sciences. Right, so if you're struggling to hear me, please make sure that your audio is on and that your speaker volume is turned up. I'm just going to highlight that because it doesn't help me saying that if you can't hear me. Right, so please make sure it's nice and loud. We've seen that if your volume isn't turned right up, you struggle to hear us sometimes. You will automatically be muted when you join into this session. Now, those of you who have joined in some of my previous sessions, I do allow some time for asking questions or providing comments with that. I will then unmute you. You can ask your question and I will mute you again afterwards. Should you have any questions, or I will ask you to put up your hands just to be a bit of interaction, just to have a bit of interaction with you guys as well during the session. You will see there's a little hand icon that you can put up. So if I say you can put up your hands, please put up your hands so that I can see that you hear me, or if you have a question. So you can quickly try that out. Press the little hand icon to see if it works and that I can see that you hear me. There's a lot of hands going up. So thank you for that. Thanks. You can also take down your own hand. And I will also on my side just take it down for now so that I can make sure there's no lingering hand over there. Okay. You can also download this presentation and any additional resources. So at this stage, only today's presentation is in PDF format in the handout box on your dashboard. So that will be available throughout this entire webinar. Please download it before we stop the broadcast of this webinar, as it will not be available afterwards on this platform. It will, however, be available on the guided learning platform under the resources tab. All of your notes of the previous weeks is also available on there. The recordings of the webinars and today's will be uploaded to our Impact channel, and I will share that link to you at the end of this webinar. Right, all of this information you can also find in the question box on your right-hand side. If you have any questions, you're welcome. I will allow time. Then you can ask your questions, or you can type your question in the question box. So at the end of the webinar, I usually go through the questions and see what I can answer here live for you guys. If there's something that I don't get to, I will provide feedback to everyone that was part of this session. We do encourage our attendees to ask questions and leave comments. But if you leave irrelevant or inappropriate comments, you will be dismissed from this session. If I did not get to your question today and you have any academics questions, you're welcome to send it through to academics@impact.co.za. The questions, like I said, will be answered in the question box. If we don't get to everything, I will send feedback to every one of you. If you do not receive it and you still have an unanswered question, you're welcome to send an email to info@impact.co.za. Then, like I said, this session and all of the other sessions that we did present already will be available on the YouTube channel. And like I said, I'll share the link. Okay. You can quickly make use of your hand again to just show me that you can still hear me and that you are ready for me to move on. Great. Yes, it seems like everyone is on board. Yeah, I'm going to take down the hand so that we can start the session. Firstly, I would like to go through the term 2 topics again, just so that you are sure of what you should do for this term, and when you work on your own, that you work on the correct topics. You can also find this in your study note, your portfolio study note that you can download from my Impact, or this is also available in your facilitator's guide. So just go and have a look at your year program, and there you will see exactly what you need to do for this term. Right, so trigonometry was first up, and we did a lot of trigonometry in the previous webinars and notes. So please go and have a look at that. Like I said, the notes is on the guided learning platform, and the webinars recordings are on the YouTube channel. Then functions. So your first notes on functions was actually provided last week. Please go and download them and work through them. I've also included some links to videos of explanations where we started with functions. Analytical geometry and number patterns. So for today, we will carry on with functions, and specifically with trigonometric functions. So functions is mainly assessed in paper 1, and you will see why I say mainly. I first want us to look at what we are going to do in functions. We will be looking at the exponential function, and this was part of the notes that was made available last week. So in this, with exponential functions, we're going to look at the standard form, the shape, talk about the intercepts, asymptotes, and the domain and range. We will also do the same for the hyperbolic function. We will still look there at the standard form, shape, intercepts, asymptotes, and the domain. The last part of functions is about trigonometric functions, sine, cos, and tan functions. We will also look at the standard form, the shape of these functions, intercepts, turning points with the sine and cos, amplitudes with the sine and cos, period, and then domain. Please make a note for yourself. Even though functions are assessed in paper 1, trigonometric functions can also be expected in paper 2. So trigonometric expressions and all of the work that we've done on that, you can expect in paper 2. Remember, I said you can expect the factorization and simplification in paper 1 of that mainly, but mainly trigonometry is in paper 2. But functions is in paper 1, trigonometric functions is in paper 1, but it can also be expected in paper 2. So please make a note that you don't forget to study these functions for your paper 2 as well. Right, so like I said, the exponential function and the hyperbolic function is discussed on the notes that is available on the guided learning platform for you. Today we will look at the trigonometric functions. Right, so you will see that I've made a point in showing that this can be, let me just get the correct pointer over here, this can be expected in paper 1 as well as paper 2. Paper 1 because it is a function, and paper 2 because it is trigonometric functions. So I've added here a Cartesian plane for you to just have a look at. Still you have the y and the x-axis that we use. In trigonometry, if you think back where we've done that, we worked with angles. And therefore, on my x-axis, I have different angles, different degrees that is indicated over here. So just as you would normally label your x-axis, you will now make use of degrees over there. Okay. Let's start with the sine graph. So this equation that you see over there, y is equal to sine theta, is not something new to you. And you know that the theta actually indicates your angle. Sin is your function and your theta is your angle. So I have put down here a simple graph and your standard graph of the standard equation of y is equal to sin theta. It's just a Sine graph as it is here. This is your standard form, and it will always start at your origin where your x and your y is 0. It will move up to a maximum point at 90 degrees. It will cut the x-axis at 180 degrees. It will move down to a minimum at 270 degrees and come back to the x-axis over there at 360 degrees. So this is one wave. This is one period. And I want you to also listen to specific jargon, terms that I use with trigonometric functions. So we are going to talk about periods, but I want you to look at this graph as well. Now, this graph here makes one complete wave, because if I carry on, it will repeat. So one complete wave in 360 degrees. It means that the period of a sine graph is normally 360 degrees. So my standard period of this graph is 360 degrees. Okay, so there's a lot of things that we need to talk about here, especially with this minimum and this maximum point. And there's specific terms that we're going to make use of. So I've indicated this maximum point as well as the minimum point. And this is the displacement of 1. You see it moved up to a maximum point where my y value is 1 and down to -1. So it actually moved 1 unit down and 1 unit up. We call this the amplitude. So it is the highest point of displacement of this graph, or the lowest point of displacement. So if I draw a line through, how much did it move up or down, that maximum and minimum point? We call that the amplitude. The symbol that we use for that luckily corresponds with the word A, and it is indicated right in front of my trigonometric expression. So what is the influence of that? In this case, A is 1 because it displaced 1 unit. So we don't write 1 times sin, right? So if it is 2, let's say A is 2. This graph will still start at 0. It will move up to a maximum of 2, go through 180 degrees and move down 2 units at 270 degrees and move back. So this either the bigger the amplitude gets, the higher this displacement will be from the x-axis. So we did talk about the period, and I said that the standard period for a Sine graph is 360 degrees. It means that in 360 degrees, it completes one wave. It's indicated with the symbol P, and you can find that in front of your degree over there. All right. The next thing I want to look at is the vertical shift. I want to move back and just talk about this period a little bit more. So if I have an increase of this period, so let's say I make my period P 2 now. So I have sin 2 theta. It means that in this normal 360 degrees, I need to fit in 2 wavelengths. So instead of reaching a maximum of 90, at 90 degrees, it will reach a maximum at 45. Go through 90. At 125 degrees, I will reach my minimum. Go through 180, and it will repeat it so that I have 2 complete waves in this 360 degrees. So this is when I increase my period. What if it is a half of theta then? It means that in this 360 degrees, I will only complete half of this wave. So it will be stretching out so that only half of that will fit into my 360 degrees. All right, we will look at that a little bit more later on as well. So the last variable that we need to talk to and the influence that it has is this vertical shift over here. So a vertical shift is a move up of the graph and a move down. It's not the amplitude that is affected. It is not the period that is affected. I really just take it and copy this graph and move it up or down a certain amount of units. So there I've drawn a graph in purple, which is then indicating the vertical shift that this expression and this equation can actually have. I showed you that I've just moved up the graph, and it's indicated with the symbol Q. It is just added to the end of this equation. So either plus Q, so plus 2 in this case, as I moved it up 2 units, or it can be -3, and then it will move down 3 units and start at -3. So it all depends on the value that they give for Q, but this Q actually represents your vertical shift. Now, all of these symbols and these parameters actually has the same influence that it have on sin. It also has on cos. So A still stands for your amplitude. P still indicates the change or your period, and Q is then your vertical shift. I do, however, want to show you what is the difference then between the two graphs. Now, if you look back here where we worked with sin, just show you the original one. We started our Sine graph, our standard Sine graph at the origin, at the point where y is equal to 0. When we get to the cos graph, it actually starts at 1. Your standard graph starts at 1, where y is equal to, so the sin started here, and my cos graph will start there. So it actually follows the same shape. It goes through 90 degrees, where my sin graph actually had a maximum. I have a minimum at 180 degrees. It actually cuts the x-axis at 270, and then a maximum at 360 degrees, right? So it's actually just a flip of the sin graph, if you want to look at it that way. Okay, so again, look here. If I carry on with this shape, it will start to repeat. So the period of a cos graph, a standard cos graph where P is 1, so it means that one wave is completed in this period, is also 360 degrees. So there I've just shown you that I start with my maximum point on the cos graphs. So I want us to talk about the tan graphs, and they are quite different. I've drawn a tan graph over here for you. Now you will see this dotted lines that is indicated, and that indicates my, so this is lines where tan will not exist, and you can actually test that. Take out your calculator and check. So say tan 90 degrees, and you will get an error. Tan to 70 degrees, and you will also get an error. This is degrees where tan does not exist. So in our demarcation of the topics that we're going to do today, we said that the amplitude is not applicable to the tan graph. And it's true. We do use this symbol, but it does not represent an amplitude because we can't say what is the maximum displacement or the maximum or the minimum point in a tan graph, as it is this funny curves that goes into infinity. Right, but this actually influences the steepness or how much this graph bends. So if I increase my A value over there, if I say 5 tan theta, the line will be less bendy, if I can use that term. So the higher this A value gets, the less it will bend. So if I now say a half of it, a half tan, it will bend even more. And I will see something like this. So I will only have a bend over there and a bend over there. So it's the degree of how much it bends. So the bendiness of this graph is influenced by this A value over here. Right. I'm going to move over to the period, and I want us to talk about this a little more. So I've said that with the sin and the cos graph, my period is 360 degrees. So in 360 degrees, my sin and my cos graph makes one wave, one complete wave. Now with tan, if I look over here, this is so this is half of this curve. This is a whole curve. And this is again half of the curve. So if I look at this where I have one complete curve that is shown over here, I can see it happens between 90 and 270 degrees. This is a 180 degree period. So in 180 degrees, tan can make one complete curve. It means that the period of a tan graph is 180 degrees. A standard tan graph is 180 degrees. Okay, so just recap, sin and cos. The period of a standard sin and cos graph is 360 degrees, and the period of a standard tan graph is 180 degrees. So what happens if I then increase this p-value? So what I've chosen is actually that my P is 3. It means that 3 waves needs to be completed in a period which is 180 degrees. So there's the original where it was one curve that will be completed in the 180 degree. But if I change my P to 3 now, it means that 3 complete curves will be fitted into a 180 degree interval. Right. So if you think about this, it means also that there's more asymptotes. You can actually see it in the graph over here. So if my period increases to 3, meaning there's 3 complete curves in here, I will have 3 times more asymptotes as well. So if I look at this interval between 0 and 360, I had 2 asymptotes. But now I have 3 times more of this graphs in here. It means I have 3 times more asymptotes. If it was originally 2, and I need to multiply it with 3, there's 6. So let's check. 1, 2, 3, 4, 5, and 6 asymptotes over there. So it also influences the number of asymptotes that I have for a specific interval. Just looking at this, and if I make my P3, it means that there's 3 times more asymptotes for the same interval, as well as 3 graphs, 3 complete curves for the same interval as well. So let's look at the vertical shift, the Q. It has the same influence as it has with sin and cos graphs. It's just moving my graph up or moving my graph down. So none of the other things changed. It's just a vertical shift up or a vertical shift down. And it's also just added or subtracted at the end of this equation. All right. Quickly put up your hands. Are you still with me? Can you still hear me? Did you follow? Up. Like I said, I will definitely allow for some questions a bit later on, but it seems like a lot of you are still following and is still with me regarding this. Right, I'm going to take down the hands for now. Okay, so I want us to look at an example of how you can expect this in question. So I've taken this specific question out of the DBE question paper of 2018, and you can see here it says actually paper 2. Like I said, you can expect your trig functions to be in paper 2 as well. So they say that the graphs of fx and gx are given. So fx is equal to a cos b theta. Let's just talk about that for a minute. So firstly, I need to look at a cos graph, and I can see a cos graph over here. You see it starts at the maximum point like we said. All right. A, we know, represents my amplitude. And if I just see 1, 2, 3 units, and if I look at the minimum 1, 2, 3 units, so I kind of already have an indication of what my amplitude is. B, in this one, represents my period over there. So they didn't use P, but they used B. But the place at which this variable stands should be an indication of what it represents. The other graph given is gx is equal to c tan theta. So we know that c indicates how bendy is this curve, right? And there's no change in my period over there. So let's just make sure. So between negative 90 degrees and 90 degrees, there is a difference of 180 degrees. And I can see that one complete curve is in that 180 degree, and that shows me that my period is 1. They've also shown you the interval for which they have drawn these graphs. So it started at negative 180 up to 180 degrees. Now, all of the examples that I have given you was from 0 to 360, but it doesn't matter. All of these graphs actually continue outside of that interval that I've shown you as well. So they just say they've drawn this graph for you from negative 180 degrees up to 180 degrees. Okay. It also tells us that these two graphs intersect at 58 degrees and 1.6, so the point P and the point Q. So there's point P, and they've given you the coordinate pair over there, and they say that Q is also a point of intersection. All right, great. So we looked at all of the information that they've given us, so we can start by reading the questions. We looked at the two different graphs. We've identified where they are. We know about the interval that they've given us. We know the points of intersection. What they didn't show us or talked about is my asymptotes, but we've used that to determine that my period are 180 degree of these tan graphs. Right. The question is, write down the range of f. Now, if you look at range, it means that it's all of my y values, and f is the cos graph. So I know that my minimum is at -3 and my maximum is at 3. It will not fall out of that interval, so that represents my range of graph f. So you will see that I've used this notation where y is an element of -3 up to 3. You can use any acceptable notation to indicate this interval. I've used this notation as it is the same as the given notation where they've given us the interval for which these graphs are drawn, but you are not forced to use the exact interval or the same notation that they've used if they don't explicitly ask for that. If m -45 degrees, -1, so they give me an x and a y value, they give me a coordinate, lies on G, determine the value of C. So they say there m is given and it lies on the graph G, which is my tan graph, and we can see that it lies on there. They've given me an x and a y value and they want me to calculate C. So if you look at that equation, gx, which actually represents y, is equal to c tan theta. And I said that theta now is your degrees, but it is on your x-axis. So I have my x value of -45 that I can substitute into my theta, and I have a y value of -1, which I can substitute into my y value over there, my gx. Then the only unknown there will be C. It means that I can then calculate it. So let's look at that. So you take your equation of the tan graph and you substitute the given values for x and y into the equation. You put onto your calculator, you are allowed to use your calculator over here. If you say tan -45 degrees, you will get that it's -1. Divide both sides with -1 and you will get that C is equal to 1. It means that I can substitute a 1 into the place of C. So it will be 1 tan theta, but we don't write a 1. So luckily, if you look at that equation over there now, it's a standard tan graph and all of it makes sense. If you look at the period and it didn't move up before because it goes through the origin and so on. So this is the formula and the equation that you can actually use with your calculations further on now. Right, so the next question is write down the values of A and B. And A and B is on your cos equation. And we said that A represents the amplitude and B represents the period. So let's just see, we actually talked about that already. So A, the amplitude, is my maximum displacement from the middle of this graph. So it didn't move up. You will see there's no +2 or +3 or -4 at the end. So it didn't move up or down. So this is my maximum displacement and it is 3 units. It means that A is 3 because my amplitude is 3. Then B actually represents my period. So if I look at this graph or this curve given over here, it is a complete cos curve. And this happened between -180 and 180 degrees. So this whole interval over here is a total of 360 degrees, right? 180 degrees plus another 180 degrees. I said that the standard period for a cos and sin graph is 360 degrees. So they complete one curve in 360 degrees, which is also happening over here. So this means that my period will be 1. So we decided now and we've seen that my amplitude is 3 and my period is 1. So I can substitute into A the 3 and the 1 we won't write. So 1 multiplied with the degree will be the degree in any case. So there I have now two complete equations that I can use further on. Right, so 6.4 says that they want us to determine the coordinates of Q. Now P and Q are the 2 points of intersection. And there's two ways that you can actually do that. So I'm first going to show the one that you're going to do with inspection. The other one will be with a calculation that I'm going to show you. So if you look at these graphs and these curves over here, the line of symmetry can be drawn through here. When I fall it on this line of symmetry, I know that the distance between these 2 points from this line of symmetry will be the same. So why do I tell you that? It means that if my y value here is 1.6, it will be negative 1.6 over here. The influence of the x values are the following. So you will see what is the distance between this given x value to this line over here. The difference between that is, and you can do that on your calculator, you can say 90 degrees minus 58 is 32. So if there was a change in this or the displacement between these x values is 32, I can then add another 32 to get here. So you will say 32 plus 90 degrees is 122 degrees. So the coordinate of Q, the x value is 122 degrees and my y value is negative 1.6. So you could have done this by just using inspection. I've done it with a calculation just to show you another way of doing it. Okay, so we know that Q is the point where F and G cut each other. They intercept each other at those 2 points. And that means that these two graphs are the same at that point. Their y values and their x values are the same. So you can say the function of fx is equal to the function of gx. Now, what I've taken over there is you still need to know that if it displaces so much in the y axis, it will do it on the negative side as well, where they cut each other. Remember, they have specific periods, specific shapes, and it is regular, so it doesn't change over the course of this interval. I can say negative 1.6 is equal to 3 cos theta. You could have also said negative 1.6 is equal to tan theta. You could use either one of the two equations given here for you. Right, I'm going to divide both sides with a 3 so that I can have a value is equal to cos theta. And how do we do that? How do we find a degree? We say second function cos and the value. You will then get your value, your degree, which is your x value of 122.23 degrees. So this is very specific and it has decimals over there. But in this case, we usually only work with whole numbers, with integers. And I can say that my x value is 122 degrees, negative 1.6 is my y value. Right, so they ask for the coordinates, meaning you need to give it as an x and a y value and in a coordinate pair. So you need to have your brackets have an x value and a y value. Right, so at 6.5, they say K lies on F, so my cos graph, such that Km is parallel to the y-axis. Calculate the length of Km. I want us to talk about that. We know that the distance between the x-axis over here and my M point over here is negative 1. Now, I don't read it from here. Please do not just read stuff if it is not explicitly given to you. So they've given that M is negative 45 and negative 1. Okay, so there k looks as if it is 2, but it's not. It goes past a little bit. So you can't just read it off. You need to calculate it over there. Okay, so how will I get this entire length? I will take the length of my y value here, so the unit of y here, which is 1, because it moved 1 unit, or it was drawn for 1 unit, as my value is -1. And I'm going to add it to the y value of this k point over here. All right, so this is how we're going to do that. So I've said that they've given us the point M, which is -45, -1, and I'm going to focus on my y values over there. I do know that the x value of M is the same as the x value of K because it didn't move horizontally. They say that it's parallel to the y-axis, meaning it goes straight up. So my x value didn't move. That is why I know that K has the same x value as M. Then you can choose, you see that actually K lies on F on the cost graph, and they've stated that as well. They say K lies on F such that, so you can substitute that X value into the equation of the cost graph. So 3 cos -45 degrees, you put that into your calculator and you get 2.1213, and it carries on. So it means that I have my y value now of my fx, of my cost graph at that specific point. So this displacement from the x-axis up to k is 2,1213. And I'm going to add this of my m, which is 1. And then the distance km will be 3.12. The last question, I want us to talk about it a bit more. So one of the influences that we didn't talk about is a horizontal shift. And how it works is that it is also indicated at your degrees. In this case, B, we talked about P that stands in front of my degrees indicates my period. But we also see things where they say, for example, in brackets, 3 cos, and in brackets, theta minus 45 degrees. When you get that bracket around your degrees with a plus or a minus of a value, it means that there was a horizontal shift. And the trick with that is that it works opposite of what you would expect. So if I have in a bracket theta minus 45 degrees, you would like to think that the graph moved 45 degrees to the negative side of my x-axis. Or when I say plus 45, that it will move to the positive side, to the right-hand side. But it's not true. It moves opposite to the sign that is given. So if I have 3 cos in brackets theta plus 45 degrees, my whole graph will move 45 degrees to the left. So plus is moved to the left. If I have theta minus 45, the minus indicates a horizontal move to the right. So please make a note for yourself. When you have in a bracket a negative or a positive with the adding or subtracting of a value with the degrees in brackets, it's a horizontal shift. When I have adding a specific number, the graph will move to the left. If I subtract a specific number, my graph will move to the right. Okay, with this being said, I want us to read this question. If the system of axes, so my graphs are staying fixed, I'm talking about my x and my y axis. If the system of axes is shift 45 degrees to the left, so visualize that your graph stays fixed. I'm taking the axis and moving it 45 degrees to the left. It actually means that my graphs moved 45 to the right. How do I indicate it? not plus 45, but negative 45. And therefore, you will then say, if I need to write down the equation that is now represented by the graph f, I will write it down as fx, my equation over there, theta minus 45 degrees, because this graph now moved 45 degrees to the right. So we've talked about a lot of things that we've defined in the previous ones, and this horizontal shift as well, and the influence thereof. So there was a lot of things that was taken into account and talked about here, and I'm sure you have a lot of questions, which I will give you time for just now. I just want to show you here, I've given you extra links that you can go and have a look at explanations or extra practice. And then this links that I've provided under the English column is English lessons that was made by Impact that you can go and have a look at. Please go and have a look at it as it has explanations and worked out examples. And then here at the bottom in red, I've provided the YouTube channel link where you can go and download all the recordings of the webinars that we have made up to this point. So this webinar's recording will be available probably by the end of the day or in next week. Okay. Remember to download your handout if you would like to have it as a PDF format, then you don't have to go and look for it on other platforms. Right, so now is your chance to ask your questions. Okay. Annabelle, how can I help you?
Hi, ma'am. In that graph, it's moved. The question said move to the left, but you minus 45.
Okay, so it says that the system of axes. So I said that you must visualize that your graphs are staying fixed. I don't talk there about the shift of the graph necessarily. They talk specifically in this question about the system of axes. So my x and y axis is taken and that is moved 45 degrees to the left. So what happens actually? What do you see in your mind? You see that the graphs in reference to the axis actually moved 45 degrees to the right. Are you with me with that?
Yeah, I understand. Thank you.
Okay, so the graph moved to the right, therefore I will say negative 45 degrees.
Yeah, thank you.
Okay, pleasure. Right, let's go down the list and see if there's any other questions over there. No other questions. No one else with a question regarding this? Okay, it seems like you are comfortable with trigonometric functions. I'm quickly going to move on to the question box and see what is over there. Jacobus said that tan 70 is equal to 2.4. If you look at the asymptotes, it's on 90 and 270. So please just put in tan 90 and you will see that it is an error over there. Right, Ernest is asking if this will be in the exam. Yes, if the June examination will be written, it will definitely be included in the examinations. Okay. I don't have any other questions over here. I'm just going back and see if there's any raised hands. Seems like someone's hand got up now. I just want to quickly check where you are. Oh. Hassan Erasmus, do you have a question?
Hi, yes, how do I install the PDF?
Don't you have Adobe Reader on your computer?
Yes, I do. I clicked on the link and it just took me to a website.
It should just open up on your side. Just go on to guided learning then, guided learning, and on the resources tab, it will also be there to download. I'm sorry, I'm not an IT. It shouldn't be something that you need to install. It's just a document that you can read.
Okay, so
Okay.
I can't install it then.
It shouldn't be something that you install. That's why I ask if you have Adobe Reader on your computer. If you do, then it should just open. If you don't have Adobe Reader, you will have to install it for free from the internet. But then it's just a normal document that you open up and read.
Okay, then
All right.
that would be it.
Thank you. Bye. Ludwig Leroux, do you have a question? It doesn't seem like Ludwig has a question at the moment. I'm just moving down here quickly. All right, it seems like I've answered all of these questions. I'm just going back to the question boxes. I see there's a lot of questions coming through there now. So Mohammed also, whatever degrees they say must be shifted, must be swap the sign. Yes, so if they talk about the shift of the graph, you just swap the sign. If they talk about the shift in the axis, you must see what the influence on the graph is. So yes, the swapping of the sign is regarding the graph itself. So just read the question very carefully, but yes, it will be the opposite of how the graph shifts. So Zachary asks if there will be a webinar for algebra. Zachary, I'm first going to finish up with functions and then check all the topics that is still left. I'm not sure how long the webinars will be presented with the lockdown. We will keep you posted. So just check when you need to register for these sessions. We usually tell you the topics. Just keep an eye out for that thing for the algebra. In 6.5, Muhammad says in 6.5 is the, I'm sorry, you made a typo here and I can't figure out what's going on. In 6.5, probably the other value, negative 90 degrees. No. So I see where you want to get the 90 degrees because I'm shifting the axis. And you think that it has a double effect on the graph. So that's why I said again, I want you, actually you should draw on a piece of plastic, you know, a plastic sleeve, draw this graphs with a white piece of paper with the axis at the back. Then I want you to take the axis, keep the plastic sleeve fixed and move the axis 45 degrees. You will see that it actually just have the influence that your graph moved 45 degrees to the right. Therefore, it's only negative 45 degrees. So there's not a double influence because we moved the axis. You guys should go and play around. So draw your graphs on a piece of plastic and then move the axis to see what's the influence on the graph. And that negative or subtracting or adding degrees to my degree in brackets is actually what you're going to write down. So only the effect on the graph is represented. I hope that is what you asked me. Right, it seems that I've answered all the questions over here and all of you are happy with the online questions, the live questions as well. So I am just going to move on for now. Right, so if you are not registered with Impact and you have some questions and you would like to find out more, you're welcome to contact us at impact.co.za. And thank you so much for each and every one of you who joined me this morning and that interacted nicely with this morning's lesson. Please be safe, take care of yourself and stay healthy. See you again. Bye-bye.